My name is David Pfeiffer. I'm part of Group 6, and this is my wind turbine project. Upon being introduced to the project, I immediately had a number of design ideas and was ready to get started. In this presentation, I will show all of the alternative designs as well as the final design and why it surpassed the others. I was tasked with creating an efficient wind turbine using the Arduino DC motor as well as the Arduino itself, while recording the power generated from the turbine with a serial monitor that I will code myself. It pleases me to say that I have created what is an efficient scaled wind turbine while meeting all required tasks and successfully utilizing the Arduino components and software. Design problems and boundaries. Our designs all have one common goal: to conveniently turn wind energy into harnessed power for practical application. But we also share a common problem. Is it possible to create a fin array that is more efficient than the standard 3 fins? We will be looking at factors such as cost efficiency as well as physical possibility to determine whether or not we can achieve this goal. Some of the boundaries. Our group faces a couple of boundaries when building an efficient scaled wind turbine. Some of these boundaries are resource availability, structural integrity of a scaled build, and artificial wind conditions as opposed to natural. Moving on is the alternative designs. The first alternative design I came up with was going to be a cylindrical structure that housed both the Arduino breadboard as well as the Arduino inside of it. When I tried building this, it proved to be both annoying as well as difficult to make this realistic, and the tower was too tall for the hardware to go anywhere else, like on the ground, and was not structurally sound to begin with. The next build I came up with would be more structure-based, given my last design was not checked in this department. The design consisted of a truss array for maximum structural integrity, but this was turned down ultimately due to the difficulty of building this at such a small scale, and it was too light, as well as the efficiency of it, when I could easily make something sturdier at this scale with much less. The final design I came up with was shorter, so the hardware can rest on the ground unlike the first design, as well as sturdy and efficient unlike my second design. I was able to use just 2 cut wood blocks to achieve a solid and sturdy design that provided the perfect height for the fin array as well as the Arduino hardware. On the right is the initial sketch. Here's a more detailed sketch of my final design with measurements. And here's a picture of the final design. Tools and programs. I used the Arduino software as well as hardware to record the DC motor power generation through the serial monitor. I also used SolidWorks to render a 3D model of my build. Design principles. A major design principle that I focused on went with the old saying, if it ain't broke, don't fix it. I say this because after a couple combined hours of trying to figure out a super efficient fin design, I realized that trained engineers have spent years working on wind turbine designs, and a freshman in college wasn't going to revolutionize wind turbines. With this being said, I held true to a structurally sound 3-fin turbine that is both efficient as well as sturdy. Another design principle that I looked at was functionality. After seeing that housing the Arduino in the build was a daunting task, I came to the conclusion that functionality over aesthetic would be what gets me a great wind turbine. So that's exactly how I went about it. And that is the end. Thank you.